Okay, the last question, we're going to try and prove this identity here. 2 sine squared over 2 tangent x minus 2 sine of 2x equals 1 over tan x. Well, this is pretty simple here, just a tan x. You could replace it with sine over cos x, or this tan with sine over cos x, but you got to start with one side, and it's almost always a good idea to start with the more complex side. But we know what we're trying to get to. 1 over sine over cos x. We'd like the whole thing just to be cos x over sine x, but let's just get started. Now, we start with the left-hand side. Now, I'm going to show you what you do. You get 2 marks for this. I mean, tan x is sine over cos x. So rub out the tan x and put sine x over cos x, and you get a mark. And then sine 2x is really 2 sine x cos x. Now, I put it over 1 because I'm creating a fraction here. And there's a technique, you just have to combine the fractions. Now, if this question is worth 6 marks, you've just got 2 of the 6 marks just by doing that very simple substitution. So you want to make sure you do that. But now if you attempt to do just a little bit of a fraction thing, and all the fraction thing is you multiply the 2 denominators together. Cos x times 1, that's your common denominator. Then you cross multiply the 1 time, the same way you would combine 3 over 5 plus 7 over 11. You multiply the 2 numbers together on the bottom, multiply these 2 things, then cross multiply. 1 times 2 sine x, that's 2 sine x. And then cos x times 2 sine x cos x. So there we go. Now you look at this thing, you'd get another mark if you just made an intelligent sort of attempt at combining these 2 fractions. But then take a look. You often factor in cancel. Do you see something here that's the same in both? And what's cos x times cos x? Well, isn't that cos squared x? I just take that one more step, and then I'm almost looking at my answer. If you watch here, let's just take a look at this. Right to here. That's right to here. All I did was factor out 2 sine x. Now I'm looking, hey, sine x over cos x, that is tan x. That is tan x. And then the last part, I factored it out. 2 sine x times 1 is 2 sine x. 2 sine x times minus cos squared. 1 minus cos squared. I remember what that was. 1 minus cos squared is really sine squared. And sine squared plus divided by sine squared, that would cancel. So this cancels with that. And 2 divided by 2 cancels. All I'm left with is 1 over sine x and cos x. That's the only thing that survives. You see, the sine squared cancels and the 2's cancel, and I'm just left with sine x over cos x. But isn't that what the right-hand side is? Sine x over cos x is really 1 over tan x. Maybe you could write one more step and say it equals 1 over tan x, but I think it's okay to say right now it equals the right-hand side. So I kept working the left-hand side. Now, what did I do again? First step, replace tan with sine over cos. Replace sine 2x with 2 sine x cos x. Then I combine these fractions. Then I factored out 2 sine x. And then I saw that 1 minus cos squared was sine squared. And then I saw a whole bunch of things canceling. The sine squared canceled, the 2 cancels, and I was left with 1 over sine x over cos x, which is really the right-hand side, and that's what I was trying to prove. A little bit tricky, but that's how you do it.